Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, here we are with our last lesson of Chapter 2, Chapter 2.1.9, more solving equations. And today is where we're going to, for the most part, leave those tiles behind and work on solving equations symbolically, and that is by just writing out the problems, showing the steps as you go, showing your work, and then declaring an answer. And of course, you'll want to check it. We've talked about checking it in the past. 7th grade, we checked our solutions. And so, you know, it's always a good idea to do that, especially when you're taking a test and you're going through and working through the problem. You want to make sure you declare the correct answer so you get the full points. It's always a good idea to check your answers, right? Okay, so moving forward, we're going to be just using these skills because these are foundational algebra skills of how you solve problems. There is this one vocabulary term that I'm not quite sure that we've quoted in 8th grade yet. The solution of an equation is the value of the variable that makes the equation a true statement. So if we go back to this example that we had yesterday, where you say 2x plus 3 is equal to x plus 7, there's an equation because it's two expressions that are said to be equal to each other. So we know that they're equal. We just have to find out what value of x makes them equal to each other. So we go through the moves where you would take away an x from each side, remove balanced sets, and that leaves you with 1x plus the 3. This x has gone away, right, because you took it away with one of those, and then the 7. So x plus 3 equals 7. Then we would take away the 3 from each side because we want to get the x by itself. So we remove balanced sets, we remove 3 from each of these, and you take 3 away from the 7, and that gives you 4. This particular version of this equation, remember, all 3 of those are equivalent equations. This is still an equation because x is a very simple expression, right? And 4 is a very simple expression, and they are equal to each other. So this is what we would consider the solution to the equation. And so that's what we're going to be doing today, is we're going to be working through a series of equations, just keeping in mind the legal moves that you need to go through in order to simplify expressions, and then also simplify when you've got an equation, whatever you're doing on both sides of the equation, like removing or adding of balanced sets. All right, so today you'll explore more equations on the equation mat, and the equation mat that you're going to use, I'm not going to use any equation mats on my end, but if you want to go onto the online book and go to the student e-tools and use those, feel free to do that. By now, you should know how to access those and how to use them. So you can still continue to use those equation mats if you want to, but I'm just going to be doing them basically symbolically, and that is writing out the problems and solving them like you would with paper and pencil. Okay, so where did I leave off? Let's just start from the beginning again. Today you'll explore more equations on the equation mat, and we'll examine all the tools you have developed so far to solve for x. While you are working on these problems, be prepared to answer the following questions. How can you simplify? Can you get the variable by itself all along? Is there more than one way to simplify? And the answer to that typically is yes, right? And just choose which legal moves you want to do in which order, but they all end up in the same place. And is there always a solution? So start off, I know I said we're not going to be doing this too much more, but bear with me. Copy these down, these equation mats down. And then your job is to record, say on your paper, write the equation. Yes, write the equation represented by these diagrams, and then simplify as much as possible, making sure that you record your work and then you declare your answer. And I would recommend that you check it, excuse me, to make sure you got everything right. Okay, so copy those down, work through the process, declare your answer, and then unpause when you are ready, and I will show you my work, and we'll see if our answers agree with each other. All right, let's see what we got here. First of all, we have to write the equation, right? So this is going to be x plus 3 minus an x minus a negative 1. That would be equal to x plus negative 2 minus an x and minus 2 negative x's. So you can tell, that looks kind of crazy in there, all those subtractions and subtracting negatives. This is the time to move, guys, flip them across the street, change the way that you write the equation so that you're adding everything together. And so we'll do KFC here and here, and I'm just going to write it all as addition. X plus 3 plus a negative x plus a positive 1 is equal to x plus negative 2 instead of minus x plus a negative x instead of minus a negative 2x plus a positive 2x. Now we can start combining like terms. Notice the x and the negative x cancel each other out, and you just end up with the 4. And here you've got this negative x canceling out with that x, but you still have the 2x and the negative 2. So at this point, what are we going to do here? We got our x's all by themselves here, so let's go ahead and add 2 to this side, so that zeroes this out, which means we also have to add 2 to this side. So we end up with 2x's is equal to 6. And now what number do you multiply times 2 to give you 6 for an answer? It is absolutely 3, and you can show that work by whatever you do to one side, do the same thing to the other. If you take 2 divided by 2 to give you 1x, you got to take 6 divided by 2 to give you the 3. So our solution here is x equals 3. As to this equation, you got 2y's minus a y minus a negative 2 is equal to negative 2 minus negative y. So once again, kind of sloppy there with all those negatives and subtracting negatives. So let's do KFC and rewrite this as 2y plus a negative y plus a positive 2 instead of minus a negative 2. And then negative 2 plus a positive y instead of minus a negative y. So now combine like terms. This ends up becoming y plus 2 is equal to y plus a negative 2. And at that point, I'm thinking that doesn't make a whole lot of sense, because if you take away the y from each side, you're left with 2 equals negative 2. And we know that's not true. So what was it that we said here? If you get a situation where you cancel out all your variables and you're left with a statement that's not true, there's no way that 2 could be equal to negative 2, then there is no value for y that could ever make those two expressions equal to each other, and so we say there's no solution. Okay? So typically, we're going to always get a solution. We're going to find out what value for x makes this a true statement. But there are some situations where that won't happen. And so when you've cleared out all your variables, but you're still left with numbers, but those numbers aren't equal to each other, right? Because that's what this mat is telling us. This is an equation. That means that this side is supposed to equal that side. And when we're doing legal moves, none of that ever changes. So if we find out after simplifying everything that this side doesn't equal that side, then means that there's no way you could ever make those be equal. So there's no solution that could ever work for that. All right. Now, I believe this is a problem where you have access to the e-tools. You can access these on the website, on your online book, I should say. So go ahead and use that if you want to, but I'm not going to manipulate these tiles. You don't even have to copy these down if you don't want to. You should make sure that you copy down the original equations properly, right? So take a look at what I've got here. Make sure you understand you got your x squared plus your 2 minus your negative 2x's is equal to x plus a negative 2 minus a negative x squared minus a 1, okay? So make sure you're looking through those. Once you've got those equations right, you don't necessarily have to manipulate the tiles on the online tool. Just go ahead and do the symbolic representations. I would represent all of the, well, actually, let me change that. I would do KFC as my first step, and from there, combine like terms, remove zeros, add or remove balance sets, and at the end, you might end up having to do a little division at the end, but those would be the standard steps that you would always take, okay? So go ahead, put that on pause again, work out. All right, let's see what you got. We rewrite it as addition problems using KFC here. I don't like minus and negative 2x, so we call it plus 2x. I don't like minus and negative x squared or a minus and negative 1, so we change those to plus x squared plus 1. Then we combine like terms, and you get, basically, this is the same. All I did was rearrange the order. And I'm a big fan of, this is how you're going to be doing it in high school. If you've got variable terms, the one that has the highest exponent, I like to list that first, and then the next one, and then the constant at the end. So I've rearranged these a little bit, but you don't have to. You can leave them how they were, but you definitely want to combine like terms to make sure you get those same numbers being added together. And now I did a few things at the same time. Let me show you. We have an x squared on each side that could be taken away. So those are gone now. Then I decided, since we have more x's on this side, I would take this one away and then one of those. And since I'm collecting my x's on the left side, I wanted to cancel that out. So we subtract 2 from each side. And when you subtract 2, that's the same as adding a negative 2. So when all was said and done, we should end up with x is equal to negative 3 as our solution for problem A. Now for problem B, once again, we do the KFC. Then we combine like terms, remove zeros. And at this point, do we have more x's on the right or on the left? We have more of them on the right. So let's go ahead and take away 1x from each side so that they cancel out here. And you're left with 1x here. So that means I want to cancel this out. And what eventually happens is the 2's cancel out on both sides, which means you've got nothing on the left side. Everything's canceled out, but that means you've got 0 over there. So 1x is equal to 0. I'm kind of curious. I mean, you would want to check that to make sure that that works. And I know it works, but here's a way that we can check that here. We say, well, if this is equal to 0 and these guys cancel each other out, then this side ends up being equal to negative 2, right? No, it ends up being the opposite of negative 2, which is positive 2, the opposite of negative 2. And on this side, this is equal to 0, this is equal to 0. So what do we end up with here? This ends up being 1, 2, 3 minus 1 is 2. And remember how the opposite of negative 2 is positive 2. So are they equal to each other? Yes, they are. So x was equal to 0. The left side was equal to 2, and the right side was equal to 2. So yeah, there's the check for you. Let me go ahead and get rid of this mess up here. And I suppose I could pause it to do this, but whatever. So yeah, our solution is 0. And then on this one, do a little KFC, rewrite it. That becomes negative x plus a negative 6 equals negative x plus a negative 6. And what do we end up with here? Everything cancels out. So this is a unique situation where, unlike no solution situation where the variables canceled out and we were left with a statement that was not true, said there was no solution to that. Well, in this situation, when everything cancels out and you just have 0 is equal to 0, that means any number that you could possibly plug in for x would always work, no matter what. Like, picture that here. If you take the opposite of 10 plus negative 6, the opposite of 10 plus negative 6, you're going to get negative 16 on each side. Well, if I say x is equal to 0, then that becomes negative 6, and this one becomes negative 6. So both of them worked. It turns out there are any number that you would choose to plug in for x would make the left side equal the right side. So all numbers are considered solutions. Great. So now let's leave those tails behind. Let's just copy down these equations, go through the process, and check to see that you got the correct answer. And I am going to make this video short. I am just going to reveal. I'm going to let you look everything over. If you have any questions about any of the work on any of these problems, just send me an email. I'll be happy to respond to you and work them out, maybe create a short little video of explanation for how we get those answers. I don't want to spend too much time going over everything what's happening here. So go ahead And let's pause it. You go through the work, and then we'll see if your answers are correct. All right, let's see how you did. Start with problem number 1. See the work that I showed. The process to get to our answer is negative. I'm sorry. Did I say -2? I think in that it's supposed to be -2, isn't it? That is supposed to be -2 in the negatory. -2. Sorry. Oh, that's sloppy. I don't like that. -2. That's much better. Okay. Let's take a look at our work for B. And this is one of those situations where the variable cancels out. And you're left with a statement that's not true. -2 is not equal to 8. So that is a no solution. For part C, combine like terms, add 9 to each side, divide by 5. You get x is equal to 3. And once again, if you tested that, this would be 12 minus 9 is 3, and 3 plus 3 is 6. Yes, that checks out. And then for the last example, we got a lot of distributive property we got to work through and combining like terms. And eventually we get to that point where y ends up being equal to -3. Okay, so hopefully from what we did last year and then what we've done this year, if you are taking the time to copy down the problems and show your work, you are learning the process, and hopefully you've got this mastered, okay? If this is still a struggle for you, we will never abandon these types of problems. They will keep showing up in the homework once or twice per week at the very least, just as review, because this is essential algebra for you to understand to be successful in. So make absolutely certain that you know how to show your work, because your high school teachers will require it, your college professors will require it. Nowhere in any school or educational system will you have math teachers that say, oh, it's okay to not copy the problem down and not show any work and just write your answer. They'll never, ever do that. So start getting in the habit of practicing it now, and you'll find that in the long run, it's actually a lot faster to try and solve these problems showing your work than it would be to try and keep track of everything mentally. In fact, by the time you get to a problem like D, you probably would just guess and be okay getting the answer wrong if you refuse to show your work. So don't do that. Don't be that person that refuses to do their work and is okay just getting the hard ones wrong. None of these are extremely difficult. It's always the same basic moves. Distributive property, KFC, combining like terms and removing zeros, adding or removing balanced sets, and then at the end, if you need to, like we did in all of these situations, in A, C, and D anyway, because B didn't have a solution, you might divide at the end, okay? So keep at it. You'll become an expert at this if you're not already, and we can move forward and start getting into some more complicated math, okay? All right, take care, bye.
Hey, feeling good, like I should.